In this next section, we're going to learn about function composition. Another operation we can do with functions is composition. Suppose a person wanted to predict how much her paycheck was going to be. The total paycheck would depend on how many hours worked. And we could write this as your total pay, so say salary, is going to be a function of time. Now, after the hourly pay was calculated, the person only gets to keep a certain percentage of the hourly pay due to taxes. And we could write this as the tax function, or in other words, a take-home function. Combining these two relationships into one function is what we call function composition. So we can compute function composition algebraically, from a table, or from a graph. In each case, the thought process is the same. You're going to apply the first function, and then you're going to apply a second function, and then you're going to get an output. So we put some value in, say x, and then we get an output from function f, and we put that output into function g, and then we get our final output. And so we can think of that as the composition of two functions. We've applied first function f, and then we've applied function g. So let's do some examples. Function composition can be written in two ways. Either you can write it in parentheses, so for example, f of g of x. And this is how you would write that first you apply one function. In this case, you would apply the function g, and then you would apply the function f. Or you can write it with a dot. So this same function could be written as f dot g of x. It's very important in each case to know what order to apply the functions. In other words, which function is first. Because function composition, you have to apply the functions in a certain order. And if you apply them in a different order, your answer is going to be wrong. So when it's written with parentheses, the function that's inside the innermost parentheses is the one that's done first. So first you would do g, and then you would do f. When it's written with a dot, the one closest to the variable is the one that's done first. So again, in this one, first you would do g, and then you would apply function f. So let's do some examples. Evaluating function composition algebraically. F of x is equal to 3x minus 2, and g of x is equal to 5 minus x. Let's find f dot g of 4. Now, this is written with a dot, and when it's written with a dot, the function that's closest to the input variable is the one that's done first. So if I were to write this in terms of the boxes, first we're going to do function g, and then we're going to do function f. And function g is 5 minus x, and function f is 3x minus 2. All right, so what we're going to do is we're going to put the number 4 first into g and find out what we get. So 5 minus 4 gives us an answer of 1. Now we take that answer and we put it into function f. So 3 times 1 minus 2 would be 3 minus 2, or in other words, 1. And so f dot g of 4 would be equal to 1. So again, let's write out those details. So first we would find g of 4. So g of 4 is 5 minus 4, or in other words, 1. And now we're going to take that number 1 and we're going to plug it into function f. So f of 1 was 3 times 1 minus 2, or in other words, 3 minus 2, or 1, giving us a final answer of 1. Let's find g dot f of 4. So in this case, f is the function closest to our input variable. So we're going to do function f first. So if we were to think about it in boxes, first would be function f, and then would be function g. And so f is 3x minus 2, and g is 5 minus x, and we're taking the number 4. But this time, the first function we're putting it into is f. If we put it into f, we're going to have 3 times 4, 12 minus 2, or in other words, 10. And then we're going to put that into function g, and so 5 minus 10 will give us our final result of negative 5. And so you can see that in the two problems, while they look similar, our answers were different. And so that's why it's really important that you pay attention to what function you apply first. Let's write out the details there. So in this problem, the first thing we did was find f of 4. And f of 4 was 3 times 4 minus 2, or in other words, 10. And then we put 10 into function g. So g of 10 is 5 minus 10, giving us a final answer of negative 5. Let's practice using the parentheses notation. Now, when you have parentheses notation, the first function you're going to apply is g, the one inside the parentheses, and that's going to be followed by x. And notice that in this case, our input is not a number, but it's a variable. So our answer is going to be a variable. So let's go ahead and set it up with boxes. So first we're going to apply function g, and then we're going to apply function f. And g is 5 minus x, and f is 3x minus 2. Sometimes it gets a little tricky when you're inputting variables, so you might take a moment and really just kind of focus on where you're going to put your input. So I just sometimes circle it so I don't get lost in the process. All right, so here we go. The first thing we're going to do is we're going to take x and we're going to put it into function g. And that simply gives us 5 minus x. Now what we're going to do is we're going to take that 5 minus x and we're going to put it in to the input of f. That's going to give us 3 times 5 minus x minus 2. And now we just have to simplify this. So 15 minus 3x minus 2, that gives us a final result of negative 3x plus 13. And so f dot g of x, or f of g of x, would be negative 3x plus 13. So notice that our input involved in x, and our output also involves an x. Let's try this next one. So in the next one, the innermost parentheses is function f. And so that's the one we're going to apply first. So first we're going to apply function f, and then we're going to apply function g. So f is 3x minus 2, and g is 5 minus x. And again, it might be helpful just to really pay attention to where you're going to be replacing the input variable. All right, so let's give this a try. So first we're putting an x into function f, and that just gives a result of 3x minus 2. Now what we're doing is we're taking that 3x minus 2 and we're putting it into function g. That gives us 5 minus 3x minus 2. Now notice that I put it parentheses around my input because it's going to be important that we subtract that whole expression. In other words, that we remember to distribute the negative. And so that gives us 5 minus 3x plus 2. And if we simplify that, we're going to get negative 3x plus 7. And so our final answer for the second one is negative 3x plus 7. So in function composition, you can either write it with dots or parentheses. What's really important is that you know which box or which function to apply first. And then once you apply the functions, then you get your final answer. If your input is a number, your output's going to be a number. If your input is a variable, your output's going to be a variable. All right, so that's probably enough for this section. Why don't you give some problems a try?